Hello, chemistry class. This is Matthew Racine, and today we are going to focus on double displacement and combustion reactions. Now let's look at the key learning targets from this section. First one is that I can write balanced chemical equations from word problems. And the second one is that I can identify 5 basic reaction types by the given reactants. Now, to review, let's go over the reaction types we've already learned. So we learned decomposition, we learned synthesis, and single displacement reactions. And now the last two are double displacement reactions and combustion reactions. So what actually is a double displacement reaction? Well, a double displacement reaction occurs when a metal replaces a metal in a compound and a non-metal replaces a metal in a compound. Now, showing this in variables, we can see that A times B plus C times D equals A times D plus C times B. Now, essentially, two ionic compounds are switching their cation or their anion, whichever way you like to think about it. I personally like to keep the cations in the same spot and just switch the anions. Now, if we look at this in a real life situation, we have Mary and Bob, they're together. We also have Caitlin and Tom together. Now, after something happens, don't know what, but after something occurs, Mary is now with Tom and Caitlin is now with Bob. Wow. Now, all these reactions occur in water, so these reactions are considered aqueous. And if a reaction is actually a double displacement reaction, a precipitate will form, and usually that precipitate is white. Now let's take a look at our first example problem. So our first example problem is we have aqueous sodium bromide and aqueous potassium chlorate, and those two compounds react. So first we need a chemical formula. So sodium bromide, NaBr, and that's reacting with potassium chloride. Potassium chloride is KCl. Now, this is the reaction where we keep the cations in the same spot. So we have Na and K. Now, like I told you before, we switch the anions. So now we're going to put chloride with sodium and bromide with potassium. So that is a double displacement reaction, but we're not done yet. Now we need to balance charges. So we can see that sodium is +1, bromine -1, potassium +1, and chlorine -1. So actually this is just a 1-to-1, so we don't actually need any coefficients here. So this is first example of a double displacement reaction. Now let's take a look at our second problem type for double displacement reactions. So we have lead nitrate reacting with sodium iodide. So first thing, get a chemical formula. So lead nitrate is PbNO3. And we know we need 2 nitrates because Pb, lead, is +2. Now that's reacting with sodium iodide. And sodium iodide is NaI. Now, let's use what we just learned and keep the cations in the same spot. So lead plus sodium. Now, we simply just switch the anions. So now we have iodine with lead, and we have 2 of those because this is +2 and this is -1. And now we have nitrate with sodium. And we only need 1 of those, so let's get rid of those. We only need 1. Now, we're not done yet because we still need to balance. So you see we have 1 lead, but look, we have 2 iodines and 1 iodine, so we need a coefficient of 2 there. But now look, we have 2 sodiums, so we need a 2 right here. Oh, but now we have 2 nitrates, but we have 2 nitrates over here. So this is your complete and balanced chemical reaction. Now let's move on to combustion reactions. Now, combustion reactions occur when a hydrocarbon reacts with oxygen to form carbon dioxide and water. And all combustion reactions are exothermic, so heat is produced. And usually it's pretty easy to see the heat. Sometimes it's in the source of a little spark, or it can even be an explosion like you see on the screen. Now, the format for these occur when a hydrocarbon is with oxygen, so you can see that CX with HY plus O2 equals CO2 plus water plus heat, because it's an exothermic reaction. Now, balancing combustion reactions are by far the hardest part of the combustion reaction, in my opinion. Over the past 5 years or so, I've noticed that my students have generally struggled with this aspect of combustion reactions. So that's what we're going to focus on today. Now, our first example problem is the combustion of ethene. Now, first we need a chemical formula, as always. So, chemical formula for ethene. C2H4. And we know that in combustion reactions, it always reacts with oxygen, and oxygen is O2. Now, the products are water and carbon dioxide. Now for the hard part, balancing the reaction. So I personally like to start with the carbons. So let's balance the carbons. So we know we have 2 here, but we only have 1 here. So let's put a coefficient of 2 in front of carbon dioxide. Now what I next like to focus on is the hydrogens. So we see we have 4 hydrogens here. Now we have 2 here, so let's put a coefficient of 2 here. Then I like to focus on the oxygens. Now we can see that we have 4 oxygens here and 2 here. We have a coefficient of 2. So for this, we need a 3 in front of the oxygen. And that is your complete and balanced chemical equation for the combustion of ethene. Now let's move to our second problem type, and this is the combustion of octane. So first we need a chemical reaction. So octane is C8, because 8 oct, and then H, octane, ane, is times 2 plus 2, so 18. We know that this reacts with oxygen gas, which is O2, and this creates carbon dioxide and water. Now we can see that from what I said previously, start with the carbons. So we have 8 carbons, and we have 1 carbon, so let's put a coefficient of 8. Now next, let's focus on the hydrogens. Well, we can see here that we have 18 hydrogens, and we have 2 right there. So let's make that a 9. So we're all balanced at this point besides the oxygens. So we have 2 oxygens here. Boy, let's see, we have 16, and then we have 9. And that equals 25. Can't do 12.5 as a coefficient. Remember, coefficients have to be whole numbers. So in this situation, we give up. Just kidding. So in this situation, what we have to do is erase the coefficients and start over. And usually if this occurs, we need to double the amount of carbons we have in the first place. So let's put a 2 here. Now we have 16 carbons. Now we can put a 16 here. That was bad, 16. Let's try that again. 16 here. Now let's move to the hydrogens. So we have 36 hydrogens. Let's mark that. and we have 2 here, so we can put a coefficient of 18. Now, lastly, we have the oxygen, so we can see that we have 2, and on the other side we have 32 and 18. So 32 plus 18 equals 50. So how can we get that in? With the coefficient of 25. And to make sure we did this correctly, we can see if we can reduce anything. A 2, 25, 16, 18. Well, in this case, we can't reduce anything, so this is the final, complete reaction of the combustion of octane. Ugh. To review, you should now be able to write complete and balanced chemical equations. You should also be able to identify all 5 reaction types: synthesis, decomposition, single displacement, double displacement, and now combustion. And if you still aren't understanding this, watch it again. If you aren't understanding it after that time, watch it 5 more times. If you don't understand it after that, watch it 10 more times. Watch it 20 more times. This is crucial to the understanding of chemistry. Very crucial. So do the form and have a nice night.